Hello friends, I welcome you in lecture number 13 on logic. In this lecture, we are going to introduce normal forms. So before defining normal forms, we discuss some terminology which is required for normal forms. Here I am writing these conjunctions. I am writing conjunction of P and Q. Similarly, I can write this type of different compound propositions in which I am using this conjunction operator. I can write P and Q and R also. You can see here we have in all these compound propositions we are using this conjunction operator, and we can use this word for conjunction. We can use product word also. Okay, remember for conjunction we will use product also. So here we have written products of some variables, and you can see in all these conjunctions or products we are using either variables or their negations. In the first product we are using variables P and Q. In the second product we are using variable P and here negation of variable Q. Here we are using negation of P and Q variable. Here we are using these three variables P, Q and R. So we can call all these as products of variables and their negations. So this type of products or conjunctions are given special name. They are called elementary products. Elementary products or elementary conjunctions means in a product either we have variable and their negations, and we are using this AND operator or conjunction operator only, and here we are not using those conditional operators. So remember, elementary products or elementary conjunctions means it is conjunction of variable and its negation. We are using AND operator, and here we allow either a variable or their negations are allowed. So this type of products are called elementary products. Similarly, we can define elementary sums. If I am using OR operator, then you can see I can write some examples here: P or Q or negation R. So all these are disjunctions, and for disjunction we will use the word disjunction will be called as sum. So here in all these three propositions we have sum of variables and their negations. So this type of sums or disjunctions are called elementary disjunctions or elementary sums. So elementary sums means it is a sum of variable and their negations. So elementary sums means sum of variables and their negations. Elementary products means product of variables and their negations. So using these two definitions, elementary products, that is elementary conjunctions, and elementary sums, that is elementary disjunctions, we can define two normal forms. First one is disjunctive normal form, which we will shortly remember as DNF, disjunctive normal form. Disjunctive normal form is nothing but this type of form. Here we are writing, we are using OR operator, and here we will use elementary products or elementary disjunctions or products. So it is that form of a given formula which is sum of elementary products, or we can say that disjunction of elementary conjunctions. For example, I can write P and Q, this is elementary product. Similarly, I can write P and negation of R, this is another elementary product. These two are elementary products, and here I am using OR operator. Therefore, this is sum of elementary product. Therefore, this is in disjunctive normal form. Similarly, we can define conjunctive normal form. So, for conjunctive normal form, we will use this word CNF. So, here we are using AND operator, and here we will have elementary sums. So, CNF means it is product of elementary sums. Product of elementary sums. For product we are using conjunction. So, conjunction of elementary disjunctions. C for conjunction. So, conjunction of elementary disjunctions or product of elementary sums. And we are familiar with elementary sums now. I can write P or Q. This is one elementary sum. Similarly, I can write Q or negation R. This is another elementary sum. I can simply write negation P or negation R. So, this is nothing but all these are elementary sums or elementary disjunctions, and we are using AND operator in between. Therefore, this is conjunction of elementary disjunctions or product of elementary sums, and that is meaning of CNF. So, I have written all these things systematically here. We again revise all these things. Conjunction is also known as product. So, either we use conjunction or product, both are synonyms. Now, what is elementary product? So, elementary product means it is the product of the variable and their negations in a formula. Similarly, disjunction is also known as sum. And what is elementary sum? It is sum of variables and their negations. And for example, suppose I consider two variables which are atomic variables. Atomic variables means they are not compound variables, or there is no logical operator in those variables. So, if P and Q are any two variables, then in all these products we can see we have variable and their negations only. Here I have only one variable. Here I have negation of P and another variable Q. Here negation of Q, P, negation of P. So, in all these products we are using variable and their negations. Therefore, they are examples of elementary products. And here we are using variables and their negations only, and we are joining by OR operator. Therefore, they are examples of elementary sums. Then we discussed about disjunctive normal form. Disjunctive normal form means disjunction means OR operator. So, we will remember in this way. Disjunction means OR operator. So, disjunctive normal form means it is disjunction of elementary conjunctions. So, here we will have elementary conjunctions. So, you can write definition in this way: a formula which is equivalent to a given formula and which consists of a sum of elementary products. Here we are using OR operator, so it is sum of all these elementary products, and this type of form is called disjunctive normal form of the given formula. Here I have written examples of DNF. Here these two are joined by OR operator, and here we can see we have variables and their negations in the product. Therefore, these two are elementary products, and this is sum of elementary products. Therefore, it is disjunctive normal form. Here also this is elementary product. here I have to write AND operator. This is another elementary product and this is OR operator. So we have sum of these two elementary products. Therefore, this is another example of DNF. Similarly, we can write definition of conjunctive normal form. CNF means here we are considering product of elementary sums. So here we will write elementary sums. Whatever we will write inside here, that will be joined by OR operator, and we will have variable and their negations only in these sums. Therefore, they are called elementary sums or elementary disjunctions. And here we have AND operator. So this is conjunction of elementary disjunctions or product of elementary sums. So definition we can write in this way: a formula which is equivalent to a given formula and which consists of a product or conjunction of elementary sums or elementary disjunctions is called a conjunctive normal form of the given formula. I have written two examples. This is variable p, and that we can consider as elementary sum. This is another elementary sum, and we are joining them by this AND operator. Therefore, this is conjunctive normal form. Similarly, here I have taken this elementary sum. This is another elementary sum. Both are joined by AND operator. So this is another example of CNF. Now be careful that if I am writing only one variable, then that we can consider as elementary sum as well as elementary product. Single variable can be treated as elementary sum or elementary product. Similarly, suppose I have this P and Q, then because I am using AND operator here, this I can treat as conjunctive normal form. I can consider P and Q as elementary sums, and because I have AND operator, I can consider this as conjunctive normal form, and I can consider this as disjunctive normal form also. In disjunctive normal form, we have sum of elementary products. So we can consider this as one product and we can consider it as sum of elementary products. So this can be treated as disjunctive normal form as well as conjunctive normal form. So we end this session by again revising this definition. CNF means conjunction. C for conjunction, another word is product, and if I start with conjunction, then it is conjunction of elementary disjunctions. Conjunction of elementary disjunctions, or we can write disjunction as sum. So conjunction of elementary disjunctions or product of elementary sums. Elementary sum means we have variable and their negations joined by OR operator. Here we allow only variables and their negations. Similarly, DNF, here we start with D, so it is disjunction, that is sum, and if I use disjunction first, I will use disjunction of elementary conjunctions or elementary products. Elementary products means we are joining variable and their negations by AND operator. So it is easy to understand these two types of normal forms, CNF and DNF. And in next lecture we will discuss that if we are given some statement formula, then how to obtain its conjunctive normal form or disjunctive normal form. And I stop here. This is all about this session. I hope you like it. Thanks for watching.